On day 14 of Advent of Code, we have Restroom Redoubt. Our goal is to figure out where robots, security robots in a bathroom will be after some time. So basically we are given a list of positions and velocities of some robots, and then we need to start processing them. Their movement is always on a straight line where we have given a position and a velocity, and the robots continues moving in that direction all the time. So at the beginning they are like here, and then they move, and for the example of their movement is that it moves in this direction. And the cool thing is that it also wraps around the edges like in Mario, so you can see it like jump out of here to here and so on. So it's just like wrapping around the map automatically. And our goal is to figure out where will the robots be after 100 seconds. So that's what we will be processing here. So for the example, it will look like this, and we need to then calculate the number of robots in each quadrant of the map. And then we get the safety factor, which is multiplication of those values. And important thing is that the robots which are on the middle lines are not counted at all, so that's something that we have to skip. And our input will have 101 and 103 width and height, so that's what we are working with. So let's try to solve this. So I will take the sample input first, and let's learn how to read it first. So I will take the example. So for a robot, so public record robot, it's gonna be a point starting point and point velocity. And now we will robots, read robots async, input reader, and we will await it. And now let's do private async task, read robots async, stream reader, and we will do yes, and we will return a list of robot like that. So or we can return just an array, that's fine. I guess we'll not be modifying it at all. So so while line async is line, so while we can read something from the input, we will be splitting that line, split by space parts. Then we will be splitting starting point will be parts 0 substring 2, because we want to skip these two, and then we want to split that by comma, and velocity will be parts 1 substring to split by comma, and we will have robots list, then we have robots, and we will add it. We will add a new robot with this as a starting point. That seems very likely. That is correct. So yes, it seems okay. I'll just put it in separate lines here. But there is, yeah. Okay, so this is the starting point. This is the velocity, and there is just a little bit more parentheses. So that's the robots. And now we return robots to array. So that gives us the initial state of robots, I hope. And then from then on, we need to calculate how they move, and that we do quite easily, I hope. So the wrapping around is basically doing modulo of 100, 1 and 103. So hopefully we should be able to just calculate the end state from the initial state easily. So we will do 102nd one. So final robots, and we will do for each robot in robots, we will just calculate the final state. So final x, or final points. Final robots will be, final x will be robot dot starting point x plus robot dot velocity dot x times 100, and then we have to modulo by 101. So modulo by 101, and final y will be 103. So, and I'm not completely sure about the negative numbers, so you'll have to check how the values look. But if it's correct, then it might be like this, and then we need to figure out the quadrants. So quadrant 2, quadrant 3, quadrant 4. And now for final robot, and yeah, actually, this is looking almost right. So the first quadrant is 0 to 50, 50, less than 50, because the 50th is the middle, right? Is it correct? 100th is the end index, and 50th index is yes, that should be it. So this should be 51, I think. So like that, then greater than 50 and less than, well, this can be just like that, I think. You don't need the boundaries, so if it's like this, then this, and then less than 51, then this is greater. Final 3 will be if it's greater, less than 50 and greater than, or less than, oh wait, let's see, if this is the third quadrant, then we will have it as greater than 51, or rather 52, 50. Is that right? Wait. If it's gonna be 1. Yes. So it should be greater than 51. Right. 51 is the boundary. Right. So this should be fine. And then 50, greater than 50 and less and greater than 51. That is the number. And then we return quadrant 1 times quadrant 2 times quadrant 3 and quadrant 4. And we want to string that. And that is it. So let's see if let's see what this does. I'm not completely sure if the modules will be correct. So let's first run it with the basic input. We'll see if we read the input correctly. That's usually the first problem. And then we will see if the results are okay. So robots, we have 0, 4, 3, minus 3. So 0, 4, 3, minus 3. So that looks good. 6, 3, 1. Yeah, that's looking fine. So we read it, and then the final robots is going to look like this. So minus 90. Okay, so it's gonna be, we need to have, we need to make sure we're not in negative numbers after the module. So let's see. And final, well, it's gonna be if final x is less than 0, and like that, just to make sure we're in non-negative numbers. Right. This data, so we have the positions like this. That seems pretty good. And now we need to get the result number, which is 21. And that is not right. So let's just check. Oh, wait. The example here is working with a smaller map, right? So yeah, 11 tiles wide, 7 tiles tall. So let's verify actually. Private const width. So it's gonna be 101. Height. We will just make sure that it's a correct number for the sample. So map width, map height. I should have done it before actually. So divided by 2. So that's that map. Let's do this. And for height, we will do map height divided by 2. And that goes here as well. So yes, that is good. So now for the sample input, it's going to be a height of 11 and 7. So that's 12. That's okay. So now let's take the full input and we'll see what happens. So I will put back my original numbers and let's hope that it will work correctly against our input file. quite a big number. And it's correct. All right. So that's the first part of the problem done. Let's continue to part 2. So during the bathroom break, someone notices that the robots seem awfully similar to the ones built and used on North Pole. If they're the same type, then there should be an Easter egg that very rarely most of the robots will arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that must elapse to make the robots display the Easter egg? So that's a very different problem from the first part. That's a definitely very, very, very different problem. We don't know anything about how the Christmas tree will look, or like what is the configuration. So that makes it a little bit complicated. The number of robots is not that huge, which is good. I mean, what I could do is to run, like what a Christmas tree will look like. It is like some kind of shape that is going to be continuous on the border. So if we look for the largest component, like the largest number of robots that are neighboring to each other, then that could be the second when this happens. So what I will definitely need to do is to something like this. So I will get the largest component on the map after a given number of seconds elapse. So something like this. I will add the method that will calculate the position of the robot at a given time, and I will take this logic and put it there. So it's gonna be starting point velocity times seconds and with map height. That is okay, and we will return final x, final y. So this will give us the position of the robot after a given time. And now we'll get the robots. And what is the fewest number of seconds? No. So we don't need the quadrants at all. We'll go for unknown number of seconds. And I don't know how many, so our best. So largest component. So something like this I will do something like this, where I will see if it's greater than max component, and in case I will store the components, the seconds and the component size, and I can also do debug right line seconds. So I know what is happening there, but now we need to implement this. So dictionary, no. Well, if there are multiple robots on the same location, we don't really care about that. It doesn't really matter. So we need to just know so it's going to be an index of the robot. So we will go from each of the robots, and we want to know what is the size of the component that starts at that robot, but we don't want to process them multiple times. So we'll do something like set point visited. So now what I will do is to kind of list of components, list of points. So points, robots, select, get position at seconds. It's not like memory efficient, but I guess it's going to be fine. So largest component, and what we will do is something like this. So for each of the points that are in the list, we will see if it's been already visited. If yes, then skip it, and if it's not, then we set it as visited at point, and then we find the component size. Oh, actually, we can calculate the component size from there. So let's do that. So private int get component size for point, and the points are points set point visited. So what we will do in here, we will start at that point and try to go around it to find how, like, do a float fill basically, breadth first search. So q point and q point and yes, component size will be 0. So while we have something in the queue, we will dequeue the current point, we add it to the component, and then for each, that's not it, for each direction in tools, directions with diagonals, I'm not sure if that's going to be needed, we will add it to, we will get the next point if it's not yet visited. Or rather, yeah, so if it's not visited yet. Yes, that's actually a good idea. We should do hash set. So we will have a hash set of the points, because it's going to be more useful to quickly query if the point is there. So that's going to be better. And now we add it as visited, and then we enqueue it. Yeah, So that will give us the size of the component. So as long as we visit the point, then we are done there. Convert from, yes, because that's hash set of point. Right. Well, technically we could have removed the points from the hash set after we visited, but I guess that's okay anyway. So when we are done here, then we return the component, largest component from that set, and return it back to here. So let's see what happens if I run this. On the input file. So here largest component is 4. Okay, so let's see what is the output. This is a pretty large number, and it doesn't happen again afterwards. So that is promising, at least. So let's see what happens if we output the state at that time. So it's 7338. So let's do $1,000. Oh, let's do yeah, 10,000 is fine. So now we will have the max component. So state output map at max component seconds. So what we'll do is do a private void output map at int seconds. I will have get the points, and basically, yes, basically just output whatever is there, but I will not output it to the console, but that would be large. So I will do a string builder and put it into a string. So append and append line, and finally we will write it into a file. So file write all text to SB. Yeah, so it's going to be output txt SB to string, and we will put it there like that. Now I will have to open the output, but it's fine. So yeah, it doesn't return any value. Let's do max component seconds. Right, so we'll see what happens there. No, not data data, but let's do input file. And let's see what happens. So it's this one. Output txt. Oh, let's open it in VS Code. Oh, nice! That's a Christmas tree. So that's definitely the right answer. So let's put it there. It's gonna be what was this? 7338. Let's put it here, and we're done. All right, that was a fun one. So very original idea, very original puzzle, but it worked out well. So I thank you for joining this interesting Advent of Code session. I will do another video to see if ChatGPT can also find the tree. And in the meantime, have a great day, and I will see you tomorrow.